Welcome once again in the class of water resource engineering. So we are learning the groundwater hydrology. In today's class, we are going to see the types of well and the methods of constructions or digging of the wells. I am Mr. Susubule, Assistant Professor, Civil Engineering Department. Now we all know the wells. Basically, the source of water from the ancient time is the open well. So we all are familiar with the wells. So here are some types of the wells. So basically these wells are divided mainly into open well as well as tube wells. Tube well is the latest invention. Later on we have uh, when we have the methods of the small borings, so at that time we invented this tube well. So it is open well is depending on the nature of the ground, the water formation to be tapped. So in the open well in unconsolidated formation, that is unlined well, well with the pervious lining, wells with the impervious lining, and duck cum bore wells. So basically, if we dig the well or bore the well with unlined walls, so it is called as a unlined well. So this is with the pervious lining. There is a lining, but the it is the porous nature of porous material, so that the if the water springs are there, and water will fall into the well through the sides. You might have seen sometime, suppose this is the well and water springs are somewhere over here. So in case of this pervious lining, this water will fall into the well and it will store the water. Next is well with the impervious lining. Obviously this lining of the well will be of pervious material. In that case the water will come from the bottom, and this is the duck cum bore well. So actually this is the kind of rough kind of well, which is dug and sometimes bored. What will happen in this case? Sometimes this horizontal boring was there to draw the water from the other springs which are in the way. So what will happen? Water is coming through this thing. Suppose this is the bore and this is also bore. So if some water spring is there, so water will come into the well through this bore, or sometimes even we can bore in the downward direction also. Next, the water wells in the hard rock formation. So again, here is the dug well in the hard rock formation. Obviously, these are dug with the machinery. And again, the dug cum bore wells in the hard rock formation, which is same as these bores. Now, the tube wells. So the first type is based on the entry of water, that is screen wells or cavity wells. So obviously, uh, in screen wells, the screens are there and water is coming into this through the screens, or in the cavity well water is stored at below. Then based on the method of construction, that is drilled well, driven well, or jetted well. So in the drill well, drilling machine has been used to drill the water. In driven, some kind of hammer is there which has been used to dig this particular well. And in jetted well, one equipment is there and water jets are there, and we use these water jets to dig the particular well. Next is based on the depth, that is shallow well and deep well. And based on the type of aquifer, so water table wells, artesian wells, as we have seen, and flowing artesian wells. So these are the basic types of the water well. So going into detail, type of water wells. Diverse geological formation require different types of wells for tapping the groundwater for irrigation and water supply. The choice of the type of well for irrigation is influenced by the size of the farm holding and the relative reference given to the private, cooperative, and public wells. So basically, initially in the country regions we have these public or cooperative wells which has been, or even this time also we have these public and cooperative wells. Even private wells are there. So there are two broad classes of the wells, that is dug well or open well, and second is the tube well. So here you can see this is the dug well. Here you can see the lining of this particular rock material, this concrete seal is there, and the well cover is there, and we have the pump. So this kind of construction you might have seen in the so many villages, or in so many cities also. Then this is the dug well with pervious concrete lining. So here you can see above here is the pervious impervious formation is there, and the pervious concrete lining for the entry of water. Here you can see. So the open wells have been major means of domestic water supply throughout the span of recorded history of mankind. As I have told you earlier, they are also used extensively in small scale irrigation compared to the tube wells. Open wells are shallow and usually used to tap water table aquifers. So, what are the properties of this thing? That is, it has the comparatively large diameter, that is 3 feet to 4 feet. Actually, in our areas, we have a big size of well other than this, right about 10 or 20 feet. Even some square wells are also there. If you see in the Konkan region particularly, we have this small kind of uh, wells. And curbing material is usually of concrete blocks with the loose joints. Water enters well through loose casing joints. These are the actually low well yields, and these are the highly vulnerable to contamination because these are the open, so one can easily contaminate the water. So what are the types of these open wells? That is unlined wells, wells with the pervious lining, wells with the impervious lining, and duct cum bore well. So classification based on entry of water of tube wells. So the screen wells. The screen permits the water to enter the well from the saturated aquifer, prevent the sediment from the entering into the well. So you might have seen sometimes in the lining itself, the well screen has been placed to prevent the sediment to entering in the well. Then second is the in that there are two types, that is strainer wells. It is essentially consist of the perforated or slotted pipes with wire mesh wrapped around the pipe with the smaller annular space between the two. And second thing is slotted pipe gravel pack wells. It uses a sorted pipe without being covered by any wire mesh. So these are the basic two types of the screen wells. Then the cavity wells. It is the shallow tube well drilled in the alluvial formation. A cavity type tube well draws water from the bottom of the well and not from the soil, as we have discussed. Then the classification based on the method of construction. So first is the drilled well, the construction using rotary cable tool, jetting, hollow rod or agar rigs. Casing material can be of steel or the PVC plastic, and most are the greater than the 15-meter deep. And second is the driven well. Cannot be driven into the bedrock. Well point driven into the ground with the post driver tripod with the weight or the sledgehammer. You might have seen this type of the driven wells, that earlier we used to follow this method, that is by using hammer and uh, the tripod system. Then the well around the common around the lakes and high water table areas. So sometimes still you might have seen these methods in the banks of the rivers, or sometime where we need to dig the less that is less than 10 meters deep. So and for the limited yield, so there we can prefer this method. This is most susceptible to contamination than drilled well because it has the less depth, and even the sometimes the higher diameter also. The jetted well. Jetted wells are constructed by employing erosive action of the stream of water to cut the hole, inside which a well screen and rising pipe can be inserted after the completion. This type of wells may be constructed in places where subsoil formation is soft enough to allow the technique to work. So here you can see these are the types. So these are the hand dug wells. These are the agar. You might have seen sometimes at the time of this piling method also. So this is the kind of agar, and this is the bore hole. That is, we have bigger machineries, and you can see the drill over here, which will drill this particular bore well. So this is the typical bore well. That is, the pipe has been placed in the bore well. This is the poly pipe. These are the screens to filter this water coming into. This is the gravel. This is the non-written wall, and this is the underground water. Now the well construction. A variety of methods are used to construct the water wells depending upon the geological conditions and intended use of the well. So the types of well constructions are: first, the extending casing down the borehole through the upper loose sediment or the rocks, but leaving the bottom portion of the borehole uncased. This type of well construction is usually used in hard or fractured rock, that is partial casing. Then second is the extending casing down the borehole through the sediment rock and placing the well screen in the aquifer. This type of well constructed is commonly used in unconsolidated sediment such as the sand and gravel, that is full casing. Then typical well construction procedures. So first, drilling operation. Drilling methods vary widely and range from digging by hand to use of very technical and expensive drilling rigs. The rig is set up over a perspective well location and drilling continues until the desired depth has been reached. Then installing the casing and the screen. Once the desired depth of the borehole has been reached, the casing and screen will be installed. The casing can be made up of different materials such as steel, plastic, and comes in the various diameters and length. Next is the installing an artificial filter pack. For some well designs, it is necessary for an artificial filter pack to be placed around the screen. This operation takes place before the grouting or sealing of the well. The filter pack consists of a graded sand or gravels which is placed around the well screen, and the filter pack removes or filter unwanted fine particles from the formation that would otherwise find a way into the well. So as here we can see, this is this filter pack. And last is the grouting the well. Grouting the well involves filling the space between the casing and borewell or borehole wall with the slurry of cement or clay. This is done to seal the area between the casing and borehole wall to prevent downward leakage of the contaminants from the surface. Now the well development. Well development is a procedure intended to maximize the well yield during the drilling operation. Damage to the formation or aquifer occurs. This happens when the drill bit cuts through the rock or sediment, leaving behind small pieces of rock or sediment that may plug the well screen and reduce the yield of the well. Also, during the drilling operation, different fluids may introduced to bore hole to remove the cutting and to prevent it from collapsing. So there are two main reasons for the well development. First is repair damage done to the formation during the drilling and to remove unwanted fluids so that the natural properties of the aquifer are restored, and the change in the physical property, that is porosity and permeability of the aquifer near the borehole so that water will flow more freely into the well. So well development methods. So air development by surging and pumping. So the air surging, the air is injected into the well to lift the water to the surface. As it reaches to the top of the casing, The air supply is shut off, allowing the aerated water column to fall, thus forcing the water in and out of the screen. Then high velocity jetting. The jetting procedure consists of operational horizontal water jets inside the screen so that the water shoots out through the screen opening. Jetting with air is an alternative method to the water jetting. Then mechanical surging. Mechanical surging is the another method of development which forces the water to flow into or out of the screen by operating a plunger up and down in the casing. Then overpumping. It is the pumping at the higher rate than the well will be pumped when put into the service. And backwashing, reversing direction of the flow through the screen opening that will agitate the sediment and remove the finer fraction and then rearrange the remaining formation particles. So in these methods, overpumping and backwashing is widely used. Now, what are the merits and demerits of the canal irrigation? So far, we have seen the well irrigation. So we'll see here the merits and demerits of the canal irrigation. So merits of the canal irrigation, that is, it is the perennial source, provides safety from the droughts, it brings the fertile sediments to the fields, and it is economical to serve the large area. And the demerits are the canal water soaks into the ground and leads to waterlogging, increase the salination and leads to marshy conditions leading to malaria and flooding. And this is the particularly wastage of water because of this large surface area is available for the evaporation, etc. So that's why it is the wastage of water. Then, what are the merits and demerits of the well irrigation? So, the merits of well irrigation, it is the simplest method. Second, it is the cheapest method because uh, as compared to the canal, it is the kind of cheapest method. Then, well is independent source of the irrigation. It can be used and when the necessity arises. The canal irrigation, in the other hand, is controlled by the other agencies, that is like a government, and it cannot be used by our desire or the will. Then some groundwater salts are useful for the crops. Those are present in the groundwater. Then it does not lead to salination and flooding problems. So there is a limit to the extent of canal irrigation beyond the tail end of the canal, while a well can be dug at any convenient place. Now the demerit. The only limited area can be irrigated. Normally for a well, it can irrigate only 1 to 8 hectares of the land. Then it is not suitable for the dry regions because we need to dig a lot for the water, and even we cannot give the surety whether water is available or not. Then overuse may be lead to the lowering of the water table. So these are the merits and demerits of the well irrigation. So this is all for today's lecture. These are the references. Thank you.